And we're going to be looking at page 309 in my book. Solving systems of linear equations by the addition method. In section 2, you looked at the substitution method. So now we're going to look at the addition method. And the instructions for it found there on page 311. So solving linear systems by addition. If necessary, rewrite both equations in the form of ax plus by equals c. If necessary, multiply either equation or both equations by the appropriate non-zero numbers. The sum of the x coefficients or the sum of the y coefficients is 0. So we're going to multiply one or both equations by a number so that when we add them together, we either get rid of the x's or we get rid of y's. And that way we'll have a new equation which is one variable. We'll find our first answer and then we'll go back and find the second answer. And again, you know, you can always check your answers by substituting it back into both equations to see that it works. So let's go to our problem. We'd like to solve. Our first one's x plus y equals 4. The second equation is x minus y equals 6. We have to decide which letter we're going to get rid of. I'm going to get rid of the y's. And at this particular point, I don't have to multiply either equation because there is a positive y and a negative y. And when I add those two equations together, excuse me, the y's cancel each other out. We add the x's and get 2x equals 10. Nice little linear equation with one variable. Divide both sides by 2, and x equals 5. There's x. Now we need to know what's y. Well, you can substitute that back into either one of the original equations. I like picking the first one. So I'll have 5 plus y equals 4. Solving for y, we're going to subtract 5 from both sides and get those cancel. Y equals 4 minus 5 is a negative 1. There's the answer for y. Now you do need to write your answer for the problem. And it's 5 comma negative 1. Do remember your answer has to be alphabetical, x and then y. And do make sure that when you add them in the very first back over here, that you got your 1x and your 1x here, that you actually do get this little 2x, to make sure you do get 2. I've seen a lot of students put them together and not get 2x. Let's go try another. You might like this method better than substitution. Might not. 3x minus y equals 11. And 2x plus 5y equals 13. And again, you do have to decide which letter to eliminate. I'm going to eliminate the y's because, well, it helps if I can spell because, doesn't it? Because of the different signs. Now, do you need to have them to be different signs? Which they are, but they need to be the same number. And I'm going to have to multiply that top equation by 5. So I'll have on the top equation 15x minus 5y equals 55. And our second equation being 2x plus 5y equals 13. And when you put those together, add the x's, you get 17x. Not any y's left, just like you wanted. And that equals 68. See, nice little linear equation, but just one variable. Divide both sides by 17. There's reduced half. And x is going to equal 4. Now I can use x equals 4 back into either one of the two original equations. I'm going to take the top one, the 3x minus y equals 11, and say that's 3 times 4 minus y equals 11. So 12 minus y equals 11. I'm going to subtract 12 from both sides. Twelves cancel right there. I'll have negative y equals negative 1. Now we are going to divide both sides by negative 1 because you do want a positive. See, y equals. And a negative 1 over negative 1 is a positive 1. So the answer for our problem is the point 4, 1. And like I said, do remember it's alphabetical, x and then y.